Currently, there are over 32,000 known near-Earth asteroids and more than 120 known short-period near-Earth comets. Each has the ability to cause untold havoc on a local level, with yet more capable of releasing enough destructive energy to bring the Earth to a complete stop. According to NASA's Center for Near-Earth Object Studies, the majority of these asteroids will not approach Earth for at least several hundred years. However, there's one hurtling through space that NASA estimates has an update that would strike Earth this year. Which dangerous asteroid is coming our way to wreak havoc? Do we have a slim chance of escaping or surviving it? Join us as we explore the terrifying deadly asteroid heading for Earth in 2024. Asteroid 2007 FT3 is currently in Earth's orbit and could make a direct hit this year. This is not the first time that NASA has found an asteroid approaching Earth, but could this be the last? More than 120 near-Earth comets with short periods and over 32,000 asteroids are known to exist at this time. In the absence of effective mitigation measures, each of these space objects poses a threat to Earth. Among these recognized asteroids, the majority are monitored by NASA's Center for Near-Earth Object Studies. This asteroid might hit Earth as early as October 2024, according to this space agency's branch. First discovered in 2007 and named 2007 FT3, scientists eventually determined that the object was an asteroid. However, they could no longer follow its trajectory after the asteroid's brief observation arc of just 1.2 days. Scientists were unable to recover it, no matter how precise their observations were. Worryingly, no one has seen it since then, until now. NASA scientists estimate that this asteroid has probably now found its way back to Earth. NASA suggests that 2007 FT3 has a probability of 0.87%, or 1 in 11.5 million chances of striking Earth in October 2024. However, there is another possibility of it striking Earth sooner this month, with the probability standing at 0.0096%, or 1 in 10 million. In both cases, the asteroid has the potential to release the energy equivalent to the detonation of 2.6 billion tons of TNT. In either case, the amount of energy released from the collision of an asteroid with Earth can cause a considerable amount of regional destruction, but wouldn't be strong enough to wreak widespread destruction. Meanwhile, a small asteroid about 3 times in size disintegrated harmlessly over Germany in January, 95 minutes before it impacted Earth's atmosphere. NASA's Scout Impact Hazard Assessment System, which monitors data on potential asteroid discoveries, gave advanced warning as to where and when the asteroid would impact. This is the 8th time in history that a small Earth-bound asteroid has been detected while still in space before entering and disintegrating in our atmosphere. The BIDE, a brilliant fireball, was created when the asteroid collided with the Earth. It could have strewn small meteorites on the ground at the impact site, which was around 37 miles west of Berlin, and could be seen from as far away as the Czech Republic. The asteroid was later designated 2024 BX1. This is one of many small asteroids that occasionally strike Earth. Although they do not present any threat to Earth's inhabitants, they can serve as a model for NASA's planetary defense capabilities, such as the impact alerts and rapid response trajectory computations offered by SCOUT. SCOUT, developed and operated by the Center for Near-Earth Object Studies at NASA's Jet Propulsion Laboratory in Southern California, automatically fetch the new data from that page, deducing the object's possible trajectory and chances of impacting Earth. SCOUT originally noted the possibility of an effect and the urgent need for additional observations. After 27 minutes and posting 3 observations to the confirmation page, the asteroid's route was refined, and the likelihood of an impact with Earth was greatly enhanced when astronomers throughout Europe sent fresh data to the Minor Planet Center. SCOUT began to refine the time and place of the 2024 BX1 impact 70 minutes after it was initially detected and reported a 100% probability of an impact with Earth. As tracking progressed and more data became available over the following hour, SCOUT improved estimates of the time and location. Since the asteroid disintegrated over a relatively populated part of the world, many photos and videos of the fireball were posted online minutes after the event. The sensitivity and sophistication of near-Earth object surveys are increasing the number of these innocuous objects spotted before they reach Earth's atmosphere. This gives NASA's Planetary Defense Program valuable training. The information acquired from these kinds of events is assisting the agency in developing plans to lessen the impact of any future detections of massive dangerous objects threatening Earth's surface. Because there are several space objects hurtling towards Earth that might bring about a large-scale destruction. After all, the Devil Comet is also headed our way. The so-called Devil Comet has a much less terrifying name, Comet 12P/Pons-Brooks. This short-period comet orbits the Sun once every 71.2 years, similar to the famous Halley's Comet. This comet is not a newcomer to the solar system scene. The comet Pons-Brooks has been known to us since 1812, when comet hunter Jean-Louis Pons noticed it at magnitude 4th. In 1883, William Brooks rediscovered the comet since earlier sightings had been insufficient to pinpoint its precise return location and timing. Some more recent scientists are trying to piece together the past and believe that the comet may have been recorded on earlier passes as far back as 1385. Why do we believe it to be larger than Mount Everest? Mount Everest, for the record, is approximately 29,032 feet tall. Now, without direct observation by spacecraft or radar, it's hard to tell how big a comet is. However, a study published in 2020 in the research notes of the AAS used the comet's brightness at the time to estimate that its nucleus, composed of ice and rock, is about 10.5 miles across. They caution that this is probably an exaggeration due to the technology they employ, making it difficult to discern the precise boundary between the comet's nucleus and the coma of gas, ice, and dust emanating from its surface. But they do say that it is larger than Everest. Regardless, it's still a massive comet, no matter how much you exaggerate its size. Just so you know, it's almost the same size, measuring in at 9.3 miles along its longest side. We know that one for sure, because we visited it with spacecraft. Why is Pons-Brooks being called the Devil Comet at all? Well, at the end of July last year, the comet had an outburst that caused it to release a great deal of gas and dust, which caused it to brighten by a factor of around 100, jumping overnight from magnitude 17 to magnitude 12. In particular, Pons-Brooks has shown such behavior before and multiple times per orbit. Nonetheless, such outbursts are erratic, unpredictable, and not very common. In the wake of the eruption, the coma took on the appearance of a horseshoe or horn shape with a black core and luminous wings or tips. This led several news organizations to dub it the Devil Comet. It was referred to as the Millennium Falcon Comet by some after the Star Wars starship. Following its outburst, the comet calmed down and maintained a constant brightness until earlier last month when it erupted once more, reintroducing the horns. Though they can't say for sure, astronomers suspect the comet's uneven gas and dust emissions are to blame for the horns. Perhaps there's a black spot on the surface that's not blowing off steam like the other two spots, so it stays that way. On the other hand, it could be a shadow effect where the comet center, often made of heavier material or even topography, seems to obscure part of the brighter material behind it from our perspective. For whatever reason, it is fundamental to the comet's structure and hence intriguing to scientists, but it's definitely not evil. Pons-Brooks travels 74.4 million miles as it completes one orbit around the Sun. At perihelion, though it is within Earth's orbit, that distance is still greater than Venus's proximity to the Sun, so you might assume that Pons-Brooks must have to fly past Earth's orbit on its way into and out of the inner solar system. On the other hand, guess what? Obviously not. Space is three-dimensional, so keep that in mind. Also, comets aren't bound to the same plane of orbit around the Sun as the planets in our solar system. Pons-Brooks has a highly inclined orbit that essentially brings it down from above the ecliptic as it rounds the Sun. So Pons-Brooks will pass between the orbits of Earth on the outside and Venus on the inside before heading out of the inner solar system again. It will not ever cross the orbit of Earth and can't pose the least bit of danger via impact. The closest it will come to our planet on this orbit is about 1.5 astronomical units in June 2024. That's 1.5 times the distance of Earth from the Sun. Thus, there is no need for concern. Yes, other asteroids are also hurtling toward Earth and could cause damage. According to NASA, the second most dangerous rock is an asteroid with the designation 2975-1950 DA. It measures a sizable 0.81 miles, weighing in at 78 million tons. Discovered in 1950, scientists lost track of it for 50 years before finding its path once again. It has a 0.29%, or 1 in 34,500 chances of hitting Earth on March 16, 2880. A time way into the future. If it does strike Earth, unlikely given how advanced civilization will be by that point, it would release the energy equivalent to 75 billion tons of TNT, which is high enough to completely wipe out humanity. Although asteroids are of great concern to scientists because of the harm they could do to Earth, NASA has invested millions of pounds into its asteroid monitoring programs for another reason. The bulk of scientific interest is largely due to their status as the relatively unchanged remnant debris in the solar system. Some 4.6 billion years ago, the solar system's huge outer planets, Jupiter, Saturn, Uranus, and Neptune, formed from a mass collection of billions of comets, and leftover pieces from this formation process are built into the comets we see today. In a similar vein, the asteroids that we observe in the sky now formed through the same processes that produced Mercury, Venus, Earth, and Mars. Comet and asteroid research is crucial for a complete comprehension of our solar system and our role within it. When the Chelyabinsk impactor, a 6-mile-wide asteroid, struck Earth 66 million years ago, the dinosaurs had no warning. Earth would be leveled by a shock wave 2 million times stronger than a hydrogen bomb. If such a large asteroid were to strike today, causing tsunamis and flattening forests, cities would collapse under the force of a seismic pulse equivalent to a magnitude 10 earthquake. A cloud of steam, heated dust, and ash would obscure the sun for a long time after the impact, causing the Earth to become extremely cold. But at least we would likely be alerted in advance. Even the end of the world could be averted if NASA has anything to say about it. NASA's Planetary Defense Coordination Office is tasked with finding, tracking, and assessing the risk associated with potentially hazardous asteroids in our solar system. "We definitely want to find all those before they find us," said Lindley Johnson, lead program executive for the Planetary Defense Coordination Office. The International Asteroid Warning Network, IAWN, is a group of astronomers from all around the world that collaborates with NASA to do this. In the event that a dangerous asteroid is headed toward Earth, IAWN has procedures in place to notify the public. The first step in assessing the threat would be for the party members who identified it to communicate findings through the IAWN. Once all parties agree that Earth should brace for impact, NASA will send out an alert. After NASA alerted the White House, the government would issue a formal announcement to the public in the event that the asteroid was approaching the United States. According to IAWN, the UN Office of Outer Space Affairs would be notified if the object was large enough to constitute an international threat. To qualify as a potentially hazardous asteroid, an object must have a diameter of more than 460 feet and must intersect Earth's orbit at a minimum distance of 0.5 astronomical units, half the distance between Earth and the Sun. Out of the approximately 2,300 asteroids that have been identified as potentially dangerous, around 153 have a diameter greater than 0.6 miles. That's big enough to trigger a catastrophe if one struck Earth. When searching for and monitoring asteroids, NASA and the other members of the IAWN keep an eye out for newly discovered asteroids as well as those that have already been identified. All their observations get compiled into a database at the Minor Planet Center. More than 34,000 near-Earth asteroids have been detected by IAWN thus far. Johnson stated that NASA can confidently estimate their orbits for at least the next century. With sufficient observational data, there's a slim chance that the potentially hazardous Bennu asteroid could hit Earth in 159 years, triggering an explosion equal to 24 nuclear bombs. But the odds of that happening are only about 1 in 2,700, according to a 2021 study. Even if Bennu would potentially approach Earth, NASA is prepared to safeguard our planet with a few tricks up its sleeve. Johnson claims that IAWN typically intercepts approaching asteroids well before they pose an imminent danger to Earth. However, in order to avert the end of the world caused by an incoming asteroid, NASA would require a minimum of 5 to 10 years prior warning. In 2021, NASA launched its first planetary defense test mission. It rammed an uncrewed spacecraft into an asteroid to shift its orbit away from Earth. The mission was a success, and NASA plans to test more deflection techniques in the future. The not very good news is, we can't unfold any of them in an instant. It usually takes a few years from the permission process all the way to launch for a mission of this kind in orbit. Therefore, in order to construct a spacecraft capable of deflecting hazardous asteroids in time, we need to identify them at least 10 years before they approach Earth. Finding and calculating the orbits of as many near objects as possible is crucial for this reason. Some of the strategies to mitigate our current effect are in our possession. The Double Asteroid Redirection Test, DART, was NASA's mission that tested the technologies for preventing an asteroid impact. The target of the mission was asteroid Dimorphos, the moonlet of the binary near-Earth asteroid Didymos. In September 2022, the DART spacecraft crashed into the moonlet, thus changing its speed and orbital period. This mission demonstrated the feasibility of future missions to deflect potentially dangerous space rocks. There's also the gravity tractor. This method employs a spacecraft that would accompany an asteroid for several years and use its gravitational attraction to pull the rock off course slowly. Asteroids of any size, composition, or shape can be maneuvered by gravity tractors because of how easily they can be controlled. It is conceivable to put an asteroid into a safe orbit. The biggest asteroids, those with a diameter of more than 1,640 feet, are the most dangerous to Earth, although it's possible they won't be able to draw them. Another option is the spray painting. When it comes to deflecting asteroids, painting is different from what you immediately think of. However, the idea is based on a real-world phenomenon known as the Yarkovsky effect, which describes how sunlight affects an asteroid's orbit. To sum up, lighter surfaces reflect more light, and darker ones reflect less light. Altering an asteroid's luminosity would allow us to alter its trajectory. It would take years, if not decades, before the method's imprecise results were apparent. However, there is plenty of time for scientists to reevaluate and try again. In the event that anything goes wrong, then after all other options have been exhausted, and an asteroid is on the verge of striking Earth, the use of a nuclear weapon could be the last resort. A nuclear detonation, of course, maneuvering involving an asteroid, not on its surface but at the correct distance from the space rock, is the goal. The mission may be executed quickly by utilizing current technology. For example, we could use a regular launch pad to launch a rocket armed with a nuclear weapon. One potential drawback is that an asteroid could fragment, leading to much more destruction. However, there would be little that NASA could do to save Earth if it just received a few months' notice. The good news is that IAWN plans to detect asteroids hundreds of years, if not centuries, before they hit. That way, we have plenty of time to attempt to prevent any disaster on Earth by acting while they are still in orbit, except we get a surprise visit from a world-ending asteroid.